Hey, good morning. Welcome to Trigonometry. We are going to talk about graphing some secants and some cosecants. So let's go ahead and give us a couple of examples here. Okay, draw. So we're going to have y equals, let's go ahead. We'll say we have 3 secant of, let's see, let's do one let's start with the easy one. Okay, so let's go with 2x minus, and then we'll pick a pi over, say, I want to do something that's like reasonably tough, but we'll go with pi minus 12. Okay. And we'll go ahead and look at that one. Okay. So the first thing we have to do is remember that secant is the reciprocal function for cosine. So my step one here is I actually have to graph a cosine with this argument right here first before I can start going off to graph a secant. So what I'm going to do is I've got 5 linear equations to solve. And the way that I tend to do this is we're going to go ahead and set this equal to 0, set this equal to pi over 2, set this equal to pi. Okay, set this equal to pi, I'm sorry, pi over 12 equals 3 pi over 2. And finally, 2x minus pi over 12 is equal to 2 pi. And you'll notice like these are the points that I would want to graph for cosine or for sine, because this is what's going to give me zeros, ones, and negative ones as we go through and graph. Okay. So I want to figure out like what do I have to do? How do I have to adjust my x's so that when I plug this x in, the answer I'm going to get for secant is going to be either undefined because the cosine is 0, or it's going to be 1. Okay. So it's going to be 0 because the cosine is 0, or it's going to be 1 because the cosine of 0 is 1, or it's going to be negative 1. So I am trying to pinpoint what x's do I need so that when I plug that x in, I get a really nice answer to come out. All right. We could try doing it other ways, but like these are the easy answers for me to graph. And that's how I'm going to scale my graph so it all looks nice and pretty and it's a nice graph for me. Okay. So that's kind of the plan that we're doing here. All right. So, and you can do these. I like to do them horizontally here simply because it lets me kind of generate a list of numbers. If you wanted to do like 5 different little postcards of these, that's fine. You can do however it makes sense for you, however you are comfortable solving linear equations. Okay. After you've done a couple, few dozen, you'll be able to do them lengthwise and it won't really matter for you, but that's how I'm going to do this. So we've got 2x equals pi over 12. Here we have 2x equals pi over 12 plus pi over 2. 2x equals pi over 12 plus pi. 2x equals pi over 12 plus 3 pi over 2. Okay. And then finally, we have 2x equals, let's make that a 12, equals pi over 12 plus 2 pi. All right. Now, for my second column here, what I really would like to do is for a lot of these problems, specifically the second one here, is we have to get common denominators here. Okay. So what I'm going to do is I'm just going to say we have 2x equals pi over 12. We're going to get common denominators. How do I turn a 2 into a 12? Well, I got to multiply by 6. So in order to get the common denominator here, we're going to multiply top and bottom by 6. This is going to be 6 pi over 12 plus 1 pi over 12. We're going to have 2x equals 6 plus 1, 7 pi over 12. Make that a 12. Okay. We're going to get common denominators for the next one, right? We have pi over 12 plus pi. Well, we have to get fractions going here. So how do I turn pi into 12? So it's 12 pi over 12. 12 pi over 12 plus 1 pi over 12 is going to give me 2x equals 13 pi over 12. Okay. And we're just going to continue that process here. So we have 2x equals, and again, we have 2's on the bottom here, multiply 6 over 6. We have 18 plus 1. We have 2x equals 19 pi over 12. Okay, I wanted to make this a column, and then the first thing I did was mess it up. So I have 18 plus 1. We have 19 pi over 12. And then finally, again, we're getting common denominators. We're going to multiply by 12 over 12 here. Another way to write 2 pi is 24 pi over 12. 24 pi over 12 plus 1 pi over 12 is going to give me 2x equals 25 pi over 12. Okay. Now, the last thing I have to do is go ahead and isolate that x. So I'm going to multiply both sides of these equations by 1/2 every time. Okay, we're just going to multiply by half. We're just going to multiply by half. We're just going to get, so my x is equal to pi over 24. The next one, we have 7 pi over 24. The next one, right, we're going to say this is 13 pi over 24. The next one is we have 19 pi over 24. And finally, we have 25 pi over 24. Okay. One of the reasons I want to do this is because 1 pi plus 6 pi would be 7 pi. 7 pi plus 6 pi is going to be 13. 13 plus 6 is going to be 19. And then we can go ahead and generate a pattern rather than solve all these equations. And if you're like, hey, I got the pattern after 3, like, that's fine. That's perfect. So we can do it that way instead. So these are my x values that I want to go ahead and graph for my cosine value. We haven't even gotten to secant yet, but we are almost there. Okay. So as I'm going through and doing this, okay, we don't have a vertical shift here at all. So we're okay with just leaving it at the axis. So we'll go ahead and do this. Okay. And we're going to go from, what's my first value? Was 1 pi over 24? Okay, so we'll go right down. We'll say this is pi over 24. And my last value is going to be 25 pi over 24. 25 pi over 24. Halfway between that, and humans are pretty good at figuring out halves. We're actually really good at that. So we're going to say that's 13 pi over 24. Okay. If you just did the first one and the last one with these linear equations, you could have averaged 1 pi and 25 pi and gotten 13. Gotten 13. That would work too. So let's go ahead and average the next to them. So we're going to end up with 7 pi over 24. Okay, and I think we end up with a 19 pi over 24 here. All right. So now what I want to do is I want to dot in my cosine. So I know I'm up here, down here, 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 and here. And I'm just going to dot this in right lightly because I don't really want to graph my cosine. I want to graph secant. Okay, now that I have my shape that I'm trying to look for, okay, and the nice thing about doing it the way I just did was, like, technically these graphs go on and on and on forever, forwards and backwards. So you could leave this list and say dot, dot, dot. And I think anybody who has gotten far enough in math to say, okay, I'd like to graph a secant will be able to pick up this pattern and be able to continue this on without having to do any kind of work on solving an equation. They would just say, oh, it looks like we're just adding 6. Like, yeah, that's exactly what we're doing. And that's how we would go through and do this. So what I'm going to do now is we're going to go ahead and dot in my asymptotes. I'll make my asymptotes red. Everywhere where cosine crosses the 0, that's actually an asymptote. Okay. So that's going to work for cosecant too, but right now we're worried about secant. All right. And now the next thing I'm going to do, what color do I want to make my graph here? We'll make it, I guess we'll make it purple or something. Indigo. There you go. It's a nice color. Okay. So now we're going to go ahead and we're going to sketch in what's going to happen for my secant value. And I'm going to come here, down, come down. And then over here, we'll just make this come up. We don't have to worry about an amplitude. That's why I left it at 1. And the thing you have to remember is that this is a waveform that's going to keep going. This is not a disjointed graph. I mean, it's disjointed where the asymptotes are, but like it's not half of a horseshoe here. It keeps going up on the other side. It keeps going up on the other side. We could show that by graphing and continuing this pattern to go out. But usually the way that the books ask for it, usually the way homework asks for it, the way that I ask for it, is to say graph one cycle. That you could pick the cycle to be somewhere different, that's okay. But usually we start from 0 to 2 pi because that's where we graph cosine, that's where we graph sine. The next thing, they might ask you a couple of questions after that. Say, okay, what's the period? where did we start? Where did we end? We ended at 25 pi over 12. We started at 1 pi, I'm sorry, not over 12, over 24. Okay. We started at 1 pi over 24. So we have the ending minus the beginning. So 25 minus 1, that gives us 24 pi over 24, which gives us just pi. If you remember the formula for the period, that is 2 pi over b. When I was taking trigonometry, I was like, and you guys are going to find this as we get to the next sections. Like, I'm not memorizing another formula here. No, you can keep that. I was like, I'm not memorizing it. So we can go up and we can say this was 2 pi. My b and the thing above was 2. So I actually ended up with a period of pi. Oh, look at that. They match. Of course they match. That's how this works. Okay. So the period is just pi units. Okay. So if they ask you, like, so doing it the way that I'm kind of showing you to do it, like all of the other questions that I can come up with are rendered. They're very they're not going to say obvious, but they're plain. They're all laid out for you to pick everything up. What's the phase shift? Okay, so the phase shift. Where should we have started? Well, we should have started at 0. Where did we start? We started at pi over 24. So here's my pi over 24. Going back to my original problem, right? We have secant of 2x minus 12 pi over 12. So we had secant of 2x minus pi over 12. The way you would technically have to write this for the horizontal shift is to say this is secant of 2. So I'll put parentheses there, I'll put brackets here rather. And we're factoring the 2 out of this piece right here. 2 minus pi over 24. We factored the 2 out, but it goes back in to make it the same thing that I started with. Yeah. So these are equivalent expressions, but the phase shift has to be with this little this B part out on the outside of it. Okay. So that's my phase shift. Okay. And again, when I was taking trig, I'm like, I'm not going to remember to do this. And factoring to me, factoring 2 out of pi over 12, like that was a little bit tough for me to see. And I get that. Like, first off, it's a fraction. Factoring it out on the bottom, I was like getting a little confused. Like, how's that going to work? I just had a hard time with it. So I was like, is there an easier way? I'm like, oh, yeah, it's just shifted. I'm like, where should I have started? Where did I start? Like, what's that difference? That's my phase shift. Okay, I know it's to the right because I started on the right-hand side, but that's how you can answer all the other questions it's going to ask you. It feels like a little bit more work, and it kind of is. Um, I'm going to make a distinction between something that's hard and something that's tedious. This is a little bit on the tedious side. Hard is like it's difficult. It's a thing that you actually have to think about. I'm like, I'm not going to think about this. I want to get through my homework. I don't want to ponder the mysteries of trigonometric functions. I just want the answers so I can move on to the next problem. I think I'm feeling how to do this. I just need more practice. So, that's what my mindset was when I was taking the class. I was just like, you're just gonna have to practice more and then figure out how to draw these things. So that is an example of how to graph a secant when we have like, oh wait, we did have a thing of 3. We did have an amplitude of 3. Let me go back and change my answer. We're going to move that to a 3. Okay, so now, like, but you didn't change the graph. I'm like, didn't I? Like, I changed the scaling on my axis so it fit the problem. So yeah, that's what you do. Okay, so yeah, you can complain about like all your graphs look the same. I know that helps because if I need a more accurate graph, then we have Desmos, we have MATLAB, we have Graphic Calculator, we have a lot of tools to get the appropriate scaling so you can actually see what the numbers are in relation to each other as far as like how this is supposed to work. Okay. But when we're trying to graph it on paper, the reason why we're going to be graphing it on paper is because when you get to calculus, they're going to have something where they're going to say like, hey, we would like the area under the curve for this secant between, say, 0 and pi over 3. Well, they won't say 0 and pi over 3. They'll say whatever this is going to turn out to be when this function equals pi over 3. So they'll say from A to B, Okay. And they're going to want like the area under this curve. And the first instruction is sketch the region that you're trying to get this area for. That's what you're going to be dealing with. So that's why we have to graph a little bit of this by hand, because they're not going to let you have a fancy calculator in calculus 2. You got to wait till a 300 level class before they let you have a calculator again. Well, a fancy one. So this is because by then they know that you don't need it for doing this, I'll say, mundane things. And that's, it's just, you've already proven that you can do it. So they're saying, okay, now that you've shown that you can do it, here's the calculator. We can go ahead and trust you with this, that we know you're gonna question it. You're gonna get the right answers out of it. Okay. But when you get to calculus, a lot of times the solution will include a sketch of the region of interest. That's why you have to be able to graph this stuff. Okay. So I hope that was helpful for everybody. Thank you very much for watching the video, and I will see you in the next video. Thank you.